Now we have another question in which we talk about light going from air to glass. Light goes from air to glass. The wavelength of light is given to us, and that is equal to 600 nanometers. Speed in air is given to us 3 into 10 raised to the power of 8 meter per second. Speed in glass 2 into 10 raised to the power of 8 meter per second. So we have to find the wavelength of light in glass. We have to find wavelength of light in glass, frequency of light in glass. We have to find wavelength and frequency of light in glass. Now we know that when light goes from one medium to the other, its wavelength undergoes a change, but frequency does not change. That means whatever is the frequency in the air, it will be same in glass also. So first we find the wavelength of light in glass. Now how to do that? First we make the statements. Wavelength in air, lambda air means wavelength in air, and that is given to be equal to 600 nanometer. Wavelength in air is this much. We have to find wavelength in glass. We have to find frequency in glass. Using the relationship speed in air upon speed in glass is equal to wavelength in air upon wavelength in glass. Putting the values, speeds we put the values of wavelengths. Whatever is unknown, cross multiply and find the value of wavelength in glass. Since we have not converted this wavelength in air in meters, it is given in nanometers. So our answer will come in nanometers. So there we put the values and cross multiply. On solving, we get this. Wavelength in glass is equal to 400 nanometer. If they say find your answer in SI units, then you must convert nanometer into meter. For the second part, find the frequency in glass. So we already know whatever is the frequency in air, same is the frequency in glass. So we will find the frequency in glass. We will find the frequency in air. Whatever is the value in air, it remains the same for glass also. So frequency in air, for that we need the formula that we have done before. Frequency is equal to speed upon wavelength. Last year also we did that. Speed is equal to frequency into wavelength. Cross multiplying, frequency is equal to speed upon wavelength. Speed in air upon wavelength in air. We get frequency in air. Speed in air, wavelength in air. Now here I have converted this nanometer into meter. Nano means 10 raised to the power of minus 9. So I multiplied 600 nanometer into 10 to the power minus 9. So this no longer remains in nanometer now. It has changed into meters. Because my final answer will come in either in hertz or in per second. We will only get that answer if we convert it. Otherwise you will not get your answer in SI units. Solving that, we get 5 into 10 raised to the power of 14 per second. Or you could even say 5 into 10 raised to the power of 14 hertz. Both the answers are correct. Well, now let us try and solve this kind of problem, numerical based upon critical angle. The question says the critical angle for a medium I critical, that is equal to 45 degrees. We have to find the refractive index of this medium. Critical angle is given to us and we need to find the refractive index. So first of all we need to find out the relationship between critical angle and the refractive index. We have done that before. Refractive index is equal to 1 upon sine I critical. So that is equal to 1 upon sine 45. Critical angle is given to be 45 degrees. And the value of sine 45 is 1 upon under root 2. So 1 upon under root 2. Which on solving under root goes on top. So answer is under root 2. So refractive index of a denser medium is equal to square root 2, or you can solve it, that goes out to be equal to 1.41.